Hello, this is Elizabeth Fisher. In this presentation, I'm going to show you how to use tables to look up thermodynamic properties. I will be doing 3 quick examples, and then I'll give you 3 problems to try for yourself. All of the problems in this presentation have temperature and pressure as the 2 variables that are specified. Okay, here's the first question. We have CO2 at 300 Kelvin and 500 kilopascals. And the question is, what phase is it in, and what are the values of its specific volume, V, and its specific entropy, S? Okay, to solve this problem, we're going to be using thermodynamic property tables similar to the ones you have in the back of your textbook. You need to find the tables for the correct chemical compound, and in this case, that would be CO2. There will be several CO2 tables, and if you don't know the phase of the material to start with, you want to start with a saturation table. That way, you can compare the values that are specified to the properties of the saturated material and then decide what the phase is. So here's the saturation table for CO2. There are ordinarily 2 different saturation tables. We are using the temperature table, which just means that it has round numbers for temperature. Let's go to the line of the saturation table corresponding to the specified temperature, 300 Kelvin. We can read the saturation pressure at 300 Kelvin from the table. And we see that Psat is equal to 6.7131 megapascals. So now, let's compare our actual pressure of the CO2, 500 kilopascals, to the saturation pressure of the CO2 at the specified temperature of 300 K. So we see that those 2 pressures are not equal, and we can conclude that we do not have saturated CO2. Next, we need to figure out whether the CO2 is superheated or subcooled. And we see that the actual pressure is below the saturation pressure, so we conclude that the CO2 is not under enough pressure to condense, and so it must be in the superheated vapor phase when it's at 500 kilopascals and 300 Kelvin. So we need to go to the superheated vapor table. Here's the superheated vapor table, which consists of several small tables, each labeled with a different pressure. We need to find the small table corresponding to 500 kilopascals, which is the same as 0.5 megapascals. Then we find the line corresponding to 300 Kelvin in the 500 kilopascals table. Then we can read the values of specific volume and of specific entropy from the table. And we can summarize what we've learned here. So here's the answer to question 1. So if we have CO2 at 300 Kelvin, 500 kilopascals, it must be in the superheated vapor phase. And we have found from the tables that its specific volume is 0.11055 meters cubed per kilogram, and its specific entropy is 2.4318 joules per gram Kelvin. And if we want it in SI units, that would be 2.4318 times 10 to the 3rd joules per kilogram K. Okay, so let's go on to question 2. Again, we have CO2 at 300 Kelvin, but this time the pressure is 50 megapascals, so much higher. It's about 500 atmospheres. And we want to find the phase, and again, we want to find specific volume V and specific entropy S. Okay, so once again, we want to start with the saturation table and read off the saturation pressure at 300 Kelvin. And as before, this would be the pressure at which CO2 would boil or condense if it happens to be at 300 K. Okay, so let's compare our actual pressure, 50 megapascals, to the saturation pressure at 300 K. We conclude that CO2 is not saturated. We see that the actual pressure is higher than the saturation pressure. That means that the CO2 is in the compressed liquid form, or we can call it subcooled liquid when it's under these conditions. So we go to the compressed liquid table. Here is the compressed liquid table, or subcooled liquid table, and it's divided into smaller tables. We need to find the small table for the pressure of interest, which is 50 megapascals. In that small table, we find the line corresponding to 300 Kelvin. Then we can read off the values for specific volume and entropy. And once again, we can summarize the answer. So at 300 K and 50 megapascals, CO2 is in the subcooled liquid phase. Its specific volume is 0.000971188 meters cubed per kilogram, and its specific entropy is 0.99325 joules per gram Kelvin. Okay, so now let's go on to question 3. Once again, CO2 is at 300 Kelvin. This time its pressure is 6.7131 megapascals. We want to know what phase is it in and what are the values of V and S. So let's go back to let's go to the saturation table again and read that the saturation pressure is 6.7131 megapascals at 300 Kelvin. If we compare that to the actual pressure, we see that they are the same. So we conclude that CO2 is saturated when it's under the conditions of problem 3. So we need to go back to the saturation table. Okay, so now let's try to read off the specific volume of CO2 under these conditions. So let's take a look at the table. We see that we actually have two different values of specific volume listed, V sub F and V sub G. V sub F is the property of the saturated liquid, V sub G is the property of the saturated vapor. Similarly, we have two values listed for S sub F and S sub G. So what can we do? If we knew the proportions of vapor and liquid present in our CO2, we could perform a weighted average to get a value for V or S under our conditions. But unfortunately, we don't know anything about the proportions of liquid and vapor present. We might have pure saturated liquid, we might have pure saturated vapor, or we might have a mixture of saturated liquid and saturated vapor of any proportions. So, without any further information, we really cannot compute V. Even though we know two different thermodynamic properties, somehow we have not fixed the state of the system in this problem. So what's going on? Well, under saturation conditions, temperature and pressure are not independent of each other, so specifying T and P does not actually specify the state of the system. So what can we say in answer to question 3? Well, when CO2 is at 300 Kelvin and 6.7131 megapascals, it is either a saturated vapor, a saturated liquid, or a mixture of saturated vapor and liquid. That's not really knowing what the phase is, but it's narrowing it down. Next, we don't have enough information to find the values of specific volume or specific entropy. However, we do know that they must lie between the values for saturated liquid and saturated vapor. So we have bounds for values of V and S. Okay, so now it's time to try this for yourself. If you would like to check whether you understand these ideas by trying these 3 problems, you can do so. So if you want to try to solve them, what you should do is pause the video, write down the problems, and then scroll back through the video to find the numbers you need from the tables that we've already used. When you're done, you can go to the last slide of the video to see the answers. And here are the answers which you can check against your own work. Thank you. Goodbye.